Okay. My name is Anna-Kaisa Kultima and this is Games Now. Games Now is an open lecture series run by Aalto University on the hot topics of game industry. If you want to take the full advantage of our content, make sure that you follow us on Facebook and YouTube and other channels. This lecture is now streamed on YouTube. One of the biggest trends within the last decade or less has been the development of game engines and other development tools. And it used to be pretty expensive to make games, and it was quite inaccessible for many to be the creator. Without affordable tools that we have in the modern game development, we would not have many of the games that we love today. Godot Engine, or Godot Engine, as I would say, is one of the hottest topics on the field of engines today. And we are super proud to have Ariel Manzur, the co-founder of Godot, to share his insight on the engine. So welcome, Ariel, to the stage. Thank you.
Thank you for having me and thank you for coming. I'm honored for the invitation. I apologize. I'm not like a professional speaker. I try to speak whenever I can, but and this was interesting. This talk, Anna-Kaisa, she proposed this title kind of, and it's an interesting question, and so it's a good excuse to talk about Godot, obviously, but it's also a good excuse to explore this question, and so I'm going to do a bit of that. As she says, it's game engine tools. They used to be something that maybe we used for, we saw them for like FPS games at first, right? So the FPS, you could mod them, and you could mod them so much that they become a new game, and then we started making new games with starting by modding games like Counter-Strike, for example. It's one example, and then eventually we started having general purpose game engines, right? And now that's the norm. So why we start with this? Why use a game engine, right? And so nowadays, it's this question is, it has multiple without programming, right? And and then somebody from the financial area will say, or from the production area will say, can I have a team of people putting content into the game and have them be productive? And those things will clash, because if you have productive tools, sometimes productive tools, you need to teach people how to use them, right? And so they're not going to be like super easy, like make the game without programming. But if you have trained people, you can make a game in a very productive way, right? So, all of these they come into account. So the short answer is because it's better. Or in my opinion, my humble opinion, it's better. I spent last week, for example, in near Silicon Valley, right? And over there, they have their way of doing things, and they were asking me like, what is the one defining aspect of what is the one defining aspect of Godot that we can say this is why you use it? And I don't know, I think a game engine is too big to have one aspect. It's always going to be it's always going to be a combination of factors that will make you decide to go for one specific engine. And sometimes you see, for example, I don't know, like a small team is more nimble, so they can say we can try this engine for a game jam, see what happens. Maybe we use it, maybe we prototype something with this, maybe not. A medium-sized team, it's more difficult, right? To put, they have a system, they're working. Maybe it's like steering the Titanic. Maybe you can't do it, or maybe you can. It takes a while. Uh, a big company, for example, one thing we saw is there's some big companies that say, uh, Unreal is great, but we don't want to pay the 5% of the revenue, right? Because they have maybe like they're thinking of like $100 million a year kind of product, and so they don't want to give up that 5%, and so they rather say, okay, we pick an engine that is not, maybe it's not perfect, maybe we spend like 1 million in it to in consultants and in trying to improve it, and then we, you know, and we save money like that. And so it's a good example of there's so many reasons why so many people pick an engine. And so uh, another short answer is it's just good to know diverse tools, right? You don't know what's going to happen in the industry in 5 years. Maybe we're all using completely different tools, completely different engines. Maybe Godot is more mainstream than it is right now. Uh, and just in general, if you are looking to make uh, diverse games, you can't be tied to one tool, right? So it's like a good thing to know, I think. And so for the long answer, I'm going to do here what I did is I pulled a lot of slides from other presentations, and we're going to do the state of Godot right now, and then introduction to the engine in terms of what is this tool, how do we use it, what is the architecture, the ideas behind it, and then a little bit about the future of, what do we plan how do we plan to continue development, and a little bit on the state of Godot will show you that we do have a viable sort of future, right? Because that's another question. The people from this $100 million company will say, "Are you going to be around in a year? Because my product, I need to keep, I need to have a long-term product, right?" And so this is in the first part probably of the presentation. So the state of Godot in 2019. So Godot is fully open source. It's an MIT license. We use third-party libraries that are compatible with this license always. Sometimes that's a bit of an issue, but we have there's ways to sort of mitigate that. Development happens on GitHub. Very big community, 800 contributions from like occasional people and like 50 core contributors. That's great. We used to be 2 people, and now there's people who can take over certain areas, like I don't know, Android. Somebody takes over Android, or somebody that's or like joysticks, right? Somebody's making sure all the joysticks works and stuff like that. That's something that 2 years ago didn't happen, maybe, or maybe a bit earlier, but it's really great for us. Hundreds of issues, hundreds of pull requests. We have a very good project manager, Remy. He's really key for this, because you have to managing this. We used to have I don't know, once a month we would look at the pull requests and see what we approve and what we don't approve. Now we have a very fast interaction. If you send a pull request, somebody will evaluate it, will talk about the standards, what we need, how to improve it, and how to merge it pretty quickly. Very active. user communities. This is something that some people uh, think it's important too. For example, so the small teams, especially, they'll say, am I going to find documentation? Am I going to find communities to help me with if I have problems, stuff like that. Uh, we have pretty big communities. We have on Steam, pretty large community. The playtime is not working right now, so if you look on Steam at how much time people use the engine, it's not accurate. We're trying to fix this. But yeah, 20,000 downloads a month. It's growing pretty quickly. Uh, Commercial adoption, companies are starting to use the engine for commercial products. Uh, Making mobile games. Mobile is the most popular platform, but Steam starting to or is growing too. There's hundreds of games every year made for mobile and like dozens for Steam. Uh, One thing to mention is we always made this tool. We always made Godot to be a commercial tool. The first game we shipped was in 2012. Around 2012 was a PSP game for retail in like a UMD, uh, and we always made it with that in mind. We used it as the tool to make games on our own studio back in Buenos Aires. Uh, the transition into an open source product and then something that companies use, it takes time because of the reason, because of, I think, my opinion, because of the money, right? Again, like the person who has this 6-figure budget, maybe 7 figures, they're risking all this money on the engine. They're not risking it on like the decision of like what do we use to, for example, if you're running a company, you have to decide what do we use to do like conference calls, right? Do we use Skype or do we use Zoom or do we use, that doesn't matter. They're gonna, whatever they decide, they'll be fine. If now when they decide what do we use for the game engine, that's gonna risk all your money on that decision. So it's gonna take time. Even if the game, even if the engine was perfect, it's gonna take them some time to sort of become comfortable with it. So, and it's starting to happen. We're seeing more and more companies starting to use the tool, and that's good. It sort of helps us, inform the development. Very popular in game jams. It's a small download. It's 20 megabytes for like a workstation, and you have all the features of like a modern 3D general purpose engine. You can run it from a pen drive plugged into the computer. No need to install something. If you need to do like a mastering, like put out like an Android thing that you upload to the Android store, you need like about 200 more megabytes. That's all. That's all the installation you need. For like a workstation, for a PC game, 20 megabytes, that's enough. So on a game jam, it's and it has all the tools, the editor, quick to export. It's an open source project, so we get donations. We are partnered with Conservancy, Software Freedom Conservancy. They are our sort of fiscal partner. It's a charity, so we can accept donations that are tax deductible and all of that. Patreon is very big. It's just people giving average of like $100 a year, something like that. Donations. We also get donations from companies that sponsor the project, and also companies that sponsor certain things. For example, Mozilla is sponsoring our development for the web platform. Microsoft is sponsoring the C# development too. So companies help out. Companies again, it takes time. Also, the games industry is used to the commercial model. You buy the product and you pay them money, and they give you a product. But the open source model, it's more like we have to figure it out all together how to how to make sure that this project is going to be around like in a year, in 2 years. How do we do this, right? And so these are some ways to do this. And so the companies are kind of learning this, and they're coming around. And we're okay with Patreon anyway, but runs on on all the operating systems. Linux is a first class citizen, mostly because we use Linux. We use mostly Linux and Windows. Very big contributor community in Europe. For I don't know why. Like when you look at the users, the stats on the website, it's like half in the US, half in Europe, and then the rest all over the world. But so yeah, so I don't know. OS X, Linux is more popular in Europe. OS X not so much, or at least that's my impression. I don't have any numbers about that. But yeah, Linux, it's a first class sort of citizen, very stable editor. Uh, we try to, uh, yeah, we, and also portability was always very important from the beginning. So, and deploys to a lot of platforms. Mobile is the most popular, obviously. Web, we're getting help from Mozilla, and web was always like it's always been kind of difficult to export to, but we always see, especially around game jams, right? People from a game jam, they'll put their game on some web, make it very easy to try. It's it's still there's work going on, but yeah. And console, there's 3 console games made with Godot nowadays. Three console games. One for PS4, one for PSP, and one for Switch. Published in February. And we're working, or this is something I'm doing kind of on the side, because you can't do it via charity, but we're working on like good console support, which is like basically it's like all of these platforms. It's like you would have like the option to also go to this. It's like export to Android or export to Switch. It's the same, or not, pretty much the same. The code base is very clean. We try to make it easy for like someone. When you come into a project with like a million lines of code, obviously it's going to take some time to get used to it. But I think we've been able to, like, now we grew this community. When we published the engine as open source, it was already very mature. It was already like a million lines of code, and so it took a while for people um, to be able to contribute good, to do good contributions. But even so, like from the beginning, people like understood very quickly the code base. They would make some, like the first week we had a pull request to add the Lua language to the engine, which was crazy because and it worked really well. We didn't like merge it because of like reasons, I don't know, philosophical reasons. I don't know if that's the right word. It didn't match with the way we do things for the engine, but it was impressive how they were able to understand enough to do it quickly, and so that's very important to us. Easy to modify. That's this goes to one of the reasons why, for example, companies pick an engine and use an engine. If you, especially the big companies, if you have, for example, one of these millions of dollars project, uh, you need some people to be like in-house who are sort of the owners of the engine. You don't want to be dependent on some outside, uh, you know, consultant company or whatever. You need some people inside who own who own it. And so if you have the source code, if you have the ability to maintain, you know, your own, maybe your own fork, maybe not, maybe you can contribute back your stuff, maybe you can do a collaboration, but that's good, and that's gonna make it easier for those people to be in your company and to be good support internally for you. And so that's another one of these reasons. Okay, so now we're gonna go into like how do we make games with this engine, right? This was kind of like some description of the engine, and so now it's like what is this tool? And so as you can see, these are slides from a different presentation, a bit older, but it's a good introduction. So Godot uses what we call a scene. A scene is basically a tree of nodes. Each node has other nodes as children. It's like a little tree. Any node can have other nodes as children. There's always one root of the whole scene tree, and every node has a function, something they do specifically, right? So nodes have names and they have properties and they have a predefined function. Here are like examples of like a sprite, something that plays music, something that gives you physics. This is like a skeleton, like a 3D skeleton, something that shows text. And you can also put logic on the nodes. You can put a script so that you can, you know, have behavior, have logic. So here's an example, right? How do we use nodes to represent a game? So if you have a windmill, you're gonna have the blades on the sort of base of the building. These are going to be meshes, like a 3D mesh. Then you have collision, like a static body, some collision shapes. Then you have, you know, some animations maybe to rotate the blades, and you know, sound, maybe some particle effects, maybe stuff like that. And you're gonna have behavior, like the windmill. Maybe you want to change the speed depending on the wind, or you want to do, I don't know, maybe it does something. Maybe it's an RTS game, and this windmill outputs things like flour for your army or something. And so, oh sorry, and so we make a little tree with all of these nodes, and we have a root, and then we use all these types of, you know, a 3D mesh, collision nodes, sound, and some scripts. Now, if we have a farm, we're gonna have a bunch of oh sorry, this part it's in Spanish. These are windmills, and these are the nodes of the windmill. So if you have a farm, you're gonna have many windmills, and then you're gonna have like the ground, and also maybe you have a town and you're gonna have many houses, right? So we need to reuse this scene, this windmill scene. So what we do is we can instance the scenes inside other scenes. So it's just like a node can have other children as nodes. We instance scenes inside other scenes, which is simply like to instance to make the root of the node, of the windmill node, we make it a child of one of the other nodes, and that's it. It's like a, infinite depth, and we simply pick a node to say this node is the root of something that I conceptually I consider to be the windmill, for example, right? Or this is a house, this is a whatever. Everything we get to decide really what is the abstraction level, because the scene is just a bunch of nodes. It doesn't really care. It's a little tree of nodes. So instancing, it lets you organize the content and reuse it, and we're going to go into all the advantages of it. So here's an example for a 2D scene. We have a root scene, a root node, I mean, with a sprite and some collision and like a sound node. And so the root is a rigid body for physics, has a sprite as a child, collision shape, and it can play sounds, and it has the script on the root. So for 2D scenes, we have a node 2D, which is a base type of like all the 2D nodes. They will inherit the node 2D type. They're blue on the editor, and they have like inheritance of the transform. The transform is like the position, the rotation, and the scale. So basically, when you move the root node, the player node, you also move all the children. So it behaves like some sort of object, right? Like in my backpack, I have a bunch of things inside. When I move my backpack, I'm moving everything that's inside the backpack, right? Something like that. This is kind of how we abstract things in the world. Like I carry my backpack, I get on the bus, and the bus driver drives the bus. He doesn't care about the stuff inside my backpack, because like things contain other things, and this is how we think of the kind of how we organize all the things we have. We're gonna go a bit more into that also, and so there's a bunch of types of 2D nodes. We have the engine has a 2D space separate from the 3D space. So the node 2D nodes, they have a position in the 2D space. For 3D, it's a similar situation. The spatial node is the root of all the 3D nodes. They have position in 3D space. They're red usually in the editor, and it's the same. When you move one node, all the children move with it. All the children that have that are in the same 3D space, and we have all the types of 3D nodes: particles, mesh, lights, cameras, etc. Right, and 3D physics. And so here's a little scene too. Cube with some lights and a camera. Oh, hold on. Okay, so these two are in Spanish. I apologize. But this is the same as the two previous types. So we have the UI, all the UI controls to make like the user interface in your game. They are part of the scene too, and so there's a control type of node, and it's the same. The UI shares the 2D space with the 2D nodes, right? Because it's part of the 2D space, and so all the UI controls that you use, they inherit from the control type. And when you use the engine editor, the Godot Engine editor, it's actually running on top of Godot Engine, and it's using all of the UI elements from the engine to sort of create. So the Godot editor is kind of like a Godot game running on top of its own runtime. And Yeah, this one is Spanish too. Sorry, but there's a bunch of nodes that are sort of generic types of node that don't have a position into 2D or 3D space, and they do things for us that are just in general. For example, animation nodes. There's the stream player nodes, the sound, the nodes that play sounds that are not positional sounds, because we have positional, like 2D positional and 3D positional sound, but you can also have like just the background sound, and so that one doesn't have a position, and so there's just generic types, right? And so we have there's a bunch of like, or like a timer, for example. A timer node is a node that will wait for some time and then shoot a signal, something like that. There's a bunch of helper nodes like that, and the animations are yellow, but I don't know what color. They're usually kind of this gray color or white, I guess. So here's a bit of a comparison. Nowadays, I hear that some other engines have like nested prefabs. So this may be an old comparison, but yeah, usually you'll see like a scene with a lot of prefabs all on the same level. And so in Godot we have this kind of nested hierarchy, and so it lets us sort of organize the scene and collaborate with people, prototype at different levels. And so the the biggest point here is that because we have different scenes that are, they can be instanced in many levels of depth, then we can let people in the team work at these different levels of depth. And so we can let the level designer doesn't care about the specifics of like your windmill scene, right? They care about placing all the windmills in the terrain. And then the programmer is working inside of a scene, maybe in those specifics, and then different artists can work at different levels or can work at separately on different objects. Maybe like you have a terrain with a house, and inside the house there's a table with some glasses, and so each member of the team can work at each different level of the scene, and they can also not care about the other levels, right? And that's something that goes with the previous example of like the bus driver who drives a bus. He doesn't care about what's on my backpack, right? I have to worry about that, but only when I pack my backpack. Then I take my backpack and I'm just thinking about where did I put my backpack, that sort of thing. And so this is it's kind of something that we don't realize, but this is how we sort of think about this is how we think of the world generally. So here's an example. Oh. This is like a 2D game, and we have, for example, all the coins, all the platforms, all the enemies, and in this case we organize this like we just put all the coins inside one parent that has all the coins, and the same with the enemies and the props, and then there's music. And so for example here you see a node with the player up there, and so this player node, you see it as just one node, but in reality it's like an instance of the player scene. And if you go inside the player scene, there's a bunch of things, but again, like the level designer doesn't care on this screen. You don't really care what's inside the player. You just want to put the player wherever they need to be, or where they need to spawn, something like that. And so we sort of see the player as a node at this abstraction level, and then we can go inside the player if we click on this folder icon next to it, and we can go inside and we can start editing that scene, like, and maybe we want to change, I don't know, the particle system when you shoot or something, and then someone else cares about that. We don't, well, or the game designer doesn't care. So basically, we abstract all the parts of the game as scenes, right? So yeah, so we have a stage with an enemy, we have a ship, we have a weapon. The weapon will shoot bullets, and so we here over there the bullets they we instance them with code, and we just add them to the scene, and they add them to the stage maybe, yeah, and a missile the same. Market, yeah. The the HUD usually we put it on the player, but sometimes on the stage and so on. So everything, including the UI, it scenes, and you can do this on like a sort of huge world, right? And so here you have that example, like maybe you have the terrain with like a house and a room and a table and a vase, or like uh, the player with the hat and so on, right? And so each different member of the team, they can worry about these different levels, and they can work together. It's easier to work together that way because you don't really clash, or you clash. There's less clashing with other people when everything is at the same level. So now this is how we organize the space, but now we need it to sort of come alive, right? Scenes are static, except for like physics. All the scenes are just going to be there statically, and so we need to put a behavior to them. And so this is why we have scripting, right? And so all nodes, any node can have a script. Any node that in your scene can have a script, and the script will give it behavior. But also we have animations. Animation in Godot is very powerful because the animation can animate every property of a node. There's a bit more ahead, but basically it's not just the position or the frame of the sprite. It's also everything, like the modulation color, or I don't know, if you have, like, for example, some gameplay parameters, like does it take damage or doesn't take damage. You can change that on the timeline of the animation. You can play sounds from the animation. You can play particle systems. Anything can change on the timeline of the animation. So the animation player can animate all the properties of the node, can be auto-played or played from scripts, and there's interpolation for all data types. So for example, if you have two positions on the timeline, the animation player will interpolate between those two positions, so your node moves sort of smoothly, unless you want it to sort of teleport, and then you can say, this is a discrete value. Like, you can say these two values are discrete, and so your node would sort of teleport to the new position. And so here you can see in the example, when you are editing the animation, these are the properties of the sprite, and you can see a key shows up next to all the properties. And so this key lets you basically put keyframes on the animation, and it's showing up on all the properties. So for example, the modulation color, you can animate that. You can change the frame on the sprite. You can even change the sprite itself, the texture on the sprite, and just anything. You can also make the sort of cutout animation type of style of animation, where you have here's an example of like a character that has like a big tree of nodes, and then each node is like a part of the character, right? Like a little skeleton in 2D. We have a 2D skeleton node also with bones that where you can put sprites and move the bones, but you can combine this with uh, like sprite animation. So for example, the legs here, uh, the legs are nodes, and so you can rotate them and move them. But the face is a sprite with multiple frames, so you can change the frame and then change the movement of the legs. You can shoot particles from these jetpacks. This is an alpaca with jetpacks, by the way, and so you can shoot particles from that from the animation. You can, and you can rotate. This is like a, well, it's very complex skeleton, very lot of work, but you get a very nice kind of character, moves really well. We also have animations trees for 3D. So on 3D, you usually have, when you're working on a 3D character, you have situations where you have like a walk animation and a run animation, and you also have like, you have the gun like this, like your character has a gun, or maybe it doesn't, and you need to combine these states, right? So running with the gun, or running normally, or walking with the gun, or stuff like that. So here you have we have an animation tree, and this is similar to what you see in other engines, but basically you connect all of these boxes, you connect them, and then you have parameters, right? So here, for example, we have the idle animation and the walk cycle, and we blend them into one. And so the script will change the blend value between them. When you start walking, it goes to walk, and then when you stop, it goes to idle. And that's how you get a smooth sort of blending between two. And then you have things like the gun is over there, and all of that. Eventually, you end up with a huge tree of things, and someone knows how to manage all of this, and so the scripting language of the engine is called GDScript. It's a typo here, Python. It's similar to Python. Uh, it's made for Godot specifically for a number of reasons. The main reasons were that we can run scripts on separate threads for things like background loading and stuff like that, maybe pathfinding, things like that. And also, it's a scripting language. It's similar to Python, similar to Lua, all of these languages, but it has native types that are used for games. For example, 3D vectors, matrices, planes, things like that. That if you are integrating Lua, for example, into the game engine, you start like moving pointers around, like passing pointers around, and that's really bad for memory allocation. So this is better. And also, there's some advantages with memory allocation as well, in terms of like we use reference counting for objects instead of a garbage collector. And so it's a dynamic typed language, similar to Python or Lua. It's designed for Godot. It doesn't have any like crazy things. It's just, it looks like a normal language. I don't know. It's made to get people to learn it very quickly, because we know like a lot of people say, oh, a new language, what I have to learn. But programmers are used to learning new languages, so we know how it has to look, so that they say, yeah, I recognize this is, and they can start using it right away. Another factor in choosing a game engine for some companies. We hear from certain companies. We hear that they have a procedure to hire people, and so the HR person, they need to see like paperwork. Like if you claim that you are a programmer, you need to show papers that say that you're a programmer. So sometimes they'll say, if you have certification for your the language that you use, that's better because the guy can show the diploma for, I know C sharp, for example. And so we don't have certification for this. We do have a C sharp module that it's becoming, it's stable now, but for mobile, I don't know the situation. But this is the main language for the engine. It's integrated with the IDE in the editor, so we have things like code completion and nice syntax highlighting, stuff like that. So how does the script works with the engine is any node can have a script, and the script is basically the script is the node in just basically like all the so the script is a class, and all the functions in the script are methods, and they become methods of the node. So if you have the node and then you call a method on the node, you're calling a method from the script, or maybe you're calling a method from the native API of the node. It doesn't make a difference. It's like the script sort of complements the node in the most straightforward way possible. You don't need to think about how do I use the script, or how you just use it. No need for global scope, because the scene is like a global. The scene, if you want a global thing, you put a global node on the scene, and so yeah. Okay, so that's an introduction. We're gonna do a workshop tomorrow about this, but it's a very basic introduction, right? There's a lot of things, and a lot of things that not everyone has tested. So uh, this is why it's an open source project. You can send issues, you can help out with the development. But that was the basic idea of the philosophy of the engine. So now I'm gonna go into a little bit about what we plan for the future, for the next year maybe. Improved 3D rendering. This is from the current renderer, but the current renderer is using GLES3 for rendering, and it looks good, but it's not very well maintained. There are no good drivers for mobile, for example. Everyone is moving to Vulkan and moving away from GL. So we're gonna make a Vulkan renderer and implement missing features. I mean, this parity with commercial engines, I'm not it doesn't describe completely what our plan is, because you want to move ahead of you want to move forward with the industry, right? The industry is always moving forward, and so I think with Vulkan we're in a good track. um, Improve performance, the usual. Improve Android is kind of a big platform, and you have to mix with Java, and it's kind of a pain sometimes having to have Java for signing and all of that. We would like to do our own signing, basically simplify the process of running your game on a phone. And also we're improving the way to make modules, like third-party modules, to integrate things like AdMob all of these like Firebase, all of these things that you need for an Android game to make money, basically. FBX support. Um, we are doing async. We're using async. Async is reverse engineering the format, so it's this kind of not the most reliable thing, but it's compatible with our license, right? So we have a way to make modules that link with third-party, restrictive libraries, but we can't really, for us, from the side of the open source organization, that's not viable for us. So Asimp, they have FBX, and so we want to have good support for FBX because sadly, yeah, it's an industry standard. GLTF looks nice, but all the artists will say, I know FBX, so where's FBX? So we're working on that. Imbu is contributing this because they're doing because all of Imbu is a company in like San Francisco, that kind of that area, and they have all their other artists, and they all say we don't know GLTF, we know FBX. So navigation, it's a this I would say is the biggest sort of area where we don't have good support because it's so like there's no, each game will have a specific need, and it's so difficult to sort of generalize, right? So it'll work as a server. This is a kind of a low level detail. um, it and so we're trying to generalize the problem of like navigation and pathfinding and all of this, and so this is a server for 2D and 3D using raycast or recast, another typo. um, you know right now we do have pathfinding, but there's no like the it's for like an app mesh, so it's like a static terrain, and so if there's something moving that becomes an obstacle, you have to somehow dodge it. And so we're gonna put generalized support for this. It's difficult to generalize, I think. Multiple window support. This is for OS Windows. We right now we don't really abstract the OS window manager layer. That's kind of a problem, not a big problem, but it's something to do. So having multiple windows for the game, for the editor, that'd be nice. Haxe, it's or Hax, I don't know how to pronounce, but it's something we would like to have because there's a lot of people who want this, and they have their they like Godot. They're using maybe some other platforms that are not long term. We don't know, so we're looking into this. GD native is it's our framework for third-party modules. So this would be one of these modules, and downloaded from the asset library. And we want to move to C++ 11. This is we tend to be conservative about this kind of thing because we want to support as many platforms as possible, and so some platforms will not have the latest version of the compilers for everything. Usually these platforms that will give you their compilers, and those are the only compilers that you get, like consoles, stuff like that. And also there are certain features in these new versions of C++ that will make the code more difficult to read and more cryptic, that sort of thing. And so we're very careful about what we allow in the code. For example, auto is not allowed, or it's allowed in very specific cases. But yeah, so we're trying to move. We're picking, the things that are useful, and we're moving to just to you know just to move forward. Yeah, contributor guidelines, stuff like that. We're working on that. For C script, we're adding instructions to have optional like static typing, and that should improve the performance, and also should improve the sort of ability to make certain tools, maybe you know uh, maybe convert to some sort of bytecode machine that can be converted to machine code, things like that. It's always better to have the static typing. It's just it's easier to improve performance that way. And better access to buffers, stuff like that. uh, GDScript, it's a dynamic type language, so it's understood that it's not gonna give you good performance, right? It's for glue code and stuff like that. But what happens usually is you make all your game in GDScript, and then there's gonna be a class that it becomes slow, and so you swap it with a C++ class, C++ node or whatever. And so if we make it so that it's less often that you have to swap your code with C++, that's a good thing. Uh, but it's very easy to do that in any case. It's very easy to swap GDScript with C++ because they all use this node interface. Better web support. Now WebAssembly, we've been waiting for a while for WebAssembly. We get a grant from, or an award from Mozilla to improve this. We're working on being able to run the editor on a web browser. That'd be nice. That will make it even easier to use the engine. And WebAssembly is I think, a good solution to run on the web. And still needs some work, but we want to work on this for the future. And WebRTC sockets, UDP on the web, and stuff like that. Networking. We have a good sort of high-level networking sort of architecture, and be nice to have it working on web games too. And this is an area where it's like a bit lacking. And this is our website. Development happens all the time, very active, and that's it, I think. Okay, so that's it. So I guess the conclusion is there's a lot of things happening with the engine, and a lot of different people, they need to see different things on an engine to say why am I going to use this engine. And so these are all the things that are going on. And so I don't know, like why. It depends on who you are and what you need to see, but we're trying to cover everything. And so we talk to the industry, we hear from them, we hear what things they need, and in the end, it's like, I think because it's better, because it lets you be more productive with the team, and that's one of the most important things. When you're making a game, the games, it's very easy to think of it as a software product, but it's more like as a content product. You will have like 10% of your team will be programmers, and then the rest are people putting content into the game. And so I think we have a good tools, good support for good workflow, and so that's a that's a good advantage we have. That's a good reason to pick an engine, I think. But there's all these other reasons, and that's all, I think. So, questions? Yeah. Uh, Thank you.
Thank you, Ariel, for the lecture. Do we have any questions in the audience? There is one already, so wait for the mic.
Hi, I'm just a simple designer, so I'm interested, will there be like a visual scripting language, kind of like Blueprints, something that would make it easier for me to prototype without a programmer?
There is now a visual scripting language. This is one of those things where some things clash with others, right? Because it's like, you know, you want a tool that professionals want to use, and so then you have to say, am I really going to use all this time to make a visual scripting? No, but I'll tell you this story. A few years ago, we had all the C-level people from Square Enix. They did a tour in India and Latin America, right? We had the CEO and the CTO and the CFO of Square Enix in our office. And so we were showing them all the stuff from the engine, the tools. We actually shipped a game produced by Square Enix a few years ago with Godot. And we were showing them the tools and everything, and the CTO said, does this have a visual scripting language, kind of like Blueprints? The same question, and we were like, no. And I was like, no, because I have all professional people here. They know how to program, they know. And the guy was like, yeah, no, but for prototyping, so it's a great question, and we have one, yeah.
That was a deep burn.
Yeah, yeah, I know.
I'll say it again for the video. Well, that was a deep burn. It hurts in here.
No. But I'm telling you, it's the same. It's a good question because it's the same that Square Enix people want that, so it's a good.
Everyone is so spoiled nowadays. There's so many kind of easy to pick up tools. I heard that there's also this is an open source community, so there is like a third-party visual scripting or easier kind of beginner level editor, maybe. Okay, I can try to get that link from the. It was in the ICGJ conference a presentation from you guys as well. Well, but is there some kind of different versions of this that would be like you can easily pick it up and then do your own version of it and bring it back to the community? So is there some specific ones that you would want to kind of highlight if someone has worked on
of what? Sorry, I didn't get it.
I mean that they would have picked the Godot engine and made their own changes for the engine and then bringing it back to the communities, like something that would be very specific for a certain use that you would pick up.
So, for example, right now there's a company in Silicon Valley that they're doing something like this. They're doing a tool to sort of it's kind of like a visual scripting thing. It looks like Scratches, the Google thing. It looks like that. And so I saw, because the visual scripting that we have now, it's a bunch of boxes with lines. And when it gets too big, it's super ugly because it's a bunch of boxes with lines and it's impossible to understand. But this other thing that it's basically it's not generic enough to put it back in Godot, but it looks great. Like you look at these blocks and it's like a bunch of blocks of things that connect together. And so I look at that and I'm like, yeah, it'd be nice to have that, maybe. But yeah, I mean, we have to do a generalized version, but it looks nice. It'd be nice to have something like that, for example.
if someone wants to participate as a community, how can they start with kind of getting involved with Godot?
So there's the GitHub page. It's where all the sort of development happens. There's a lot of there's a community sort of community page on the website where you see all the communities, and so we have there's a Facebook, there's a Reddit, there's IRC, there's a Discord, and so I don't know each one of these there's going to be a different audience or different type of audience on each. For example, I'm kind of old, so I don't go into the Discord. I hear that the Discord is like a place where there's memes and stuff like that. I've never been, so I'm on IRC, for example, and so it's it's that kind of thing. We have one of these like where you post questions. We have there's a Reddit, and so you have to sort of look around. There's a lot of communities, yeah.
We're super happy that you're on IRC. IRC is a
Yeah.
Finnish invention, as you probably
Really?
know that. Yeah,
Oh,
it is.
cool.
Yeah.
That's great.
Do we have other questions from the audience? There is one. So yeah, it was developed in the 80s, I think, in the University of Oulu. If maybe somebody remembers this better. Yeah, at Oulu.
Cool.
Hi. So I would like to ask about the node system. Like, I assume you're familiar with the prefab system in Unity, or not. Well, I'd like to ask because the node system seemed really familiar with the one in Unity, but Unity uses, at least in terms, prefabs. But the thing works like there is like objects that have child objects. So is that exactly the same thing as the node thing you talked about?
Well, I would say that the Unity thing seems familiar to Godot and not the other way around. Because when we started using this about 10 years ago, and so yeah, I understand that they have like nested prefabs and they have like infinite levels, right, of nesting, and so that could be a similar. What I would say is we have a very clear sort of idea of there's very few elements, right? You have the node, and then everything's a node, except for the things that are not nodes, which are called resources. A resource is like a texture or like a 3D geometry. It's where your data is, right? And so you can have two sprite nodes, and they both have the same texture resource. So they're both pointing to the same image. That way you don't have the image twice in memory, right? Because you want to show the same sprite twice, but the data is in one place. And so the idea is the entire thing is made of nodes and resources. And so that is very simple concepts. And from those concepts, you get the complexity of your scene. They come from these very simple concepts. And I don't know how the prefabs work. The idea I got is that it wasn't that simple. It was like there's a lot of like special case things that give you the behaviors that you need, and it's like everything's a special case or something. And so, but again, I'm not aware. I'm not a big user of other engines, so I couldn't. Sorry, I couldn't go into specifics.
Thanks.
Another one. Here is the next question.
I'm trying to think how best to phrase this. I went to a few, and I don't want to get into a kind of war of engines thing. I don't think anyone cares. Like everyone likes them all equally, I think. But I just remember going to some talks last year, and I'm coming more from like content creation side of things. And there was a real feeling of, at least in that presentation, of Unity sort of moving away from this sort of independent base that it started with. Yeah, and sort of moving more towards sort of monetization and sort of as how best to sort of go on that end and statistics and things like that. And I guess at the moment, Godot's very exciting. It's a new project. I guess the two questions I just want to ask is, is the sort of long-term goal of Godot to sort of stay on this end of sort of, with the creator, or is there a sort of more ambitious, goal in the long run? And the other thing is, are there more plans, at least on the higher end of the structure, to sort of collaborate with other open source engine projects, like the Blender community has a similar philosophy and perhaps similar goals in that way, and I just wondered if there were any, aside from within the community itself, any sort of structural plans to grow on that.
Yeah, so obviously being an open source project means that it's very difficult to close it, right? And so maybe someone can fork Godot and then it becomes a commercial product or something like that. But there's always going to be the open source. The code will be out there, and so you need. I understand that's not enough, right? You need people who, and especially for a product like that, you need people who understand the industry. One of the reasons we started an open source engine is because we saw that there wasn't anything like that. There were other engines, but they were sort of usually like hobby projects or just old technology that they decided to open. But nothing like, we can use this to make commercial games. We were running like studios back in Argentina with 20 people making games for clients and stuff like that. We needed to pay the bills. And so this kind of a tension, but it goes to saying you have the code, and so then you need some people to lead the project in a way that the industry, that it's a product that the industry can use, and then with that you can keep it alive forever. And so if someone comes and says, I'm going to make a commercial product with this, they can have their commercial product because it's an MIT license. They're allowed to do that, but they can't impose on you some new license, right? They can't say, okay, from now on you have to use this cloud service or this ad service if you want to use Godot. That can never happen. The other question, we really like Blender, for example. We met with them a couple months ago, and we need an entire ecosystem of tools to be open source in order to have a viable sort of open source, the whole stack of game development to be open source. And so we want to help them. They have some issues. Blender, they're more like movie people, right? They go to Cannes, for example. And so I was there and I asked them, are you going to go to GDC? And they were like, I don't know. And so that's how, but they understood that the games industry is a lot bigger than the movie industry, the film industry. So they understand that. They're trying to get into it more, and we're trying to help them. There's a few others. I think Blender's the biggest one, and it's sort of reflects the industry in general. Like, if you're starting a big 3D game, your biggest problem is how do you get the 3D things from Maya to the game engine, or from Blender to the game engine, or whatever. And so a lot of work goes into that. And Blender is the best supported tool right now, for example, 3D. So would love if they could work on the games industry too.
That's good. Maybe to this kind of, let's talk about a little bit your personal motivation to start an open source project. How did you kind of choose to do that and not to go to the other direction?
I think many reasons. Well, we didn't see any other engines back then, or maybe today maybe I don't know how it is today, but there wasn't other engines back then. There was also a little bit of sort of our personal situation, being in Buenos Aires as opposed to being in Silicon Valley, right? It's if you're, or even here in Europe, if you're in this kind of places, it's easier to sort of start a commercial thing, get investors, get raise some money, and then try to make a product. Uh, Over there, it was a good way for us to sort of make an entrance into the industry, to say we make this thing, it's pretty unique, and we know how to make it work, and so so we went for it, and so that worked for us in terms of like I can get work as a consultant, as an engine consultant, because people know me from being this guy who made this open source engine, and so that's I think those are the two aspects. Like, we like open source, we use it, we use Linux, and so it's a good thing to be able to contribute that, and also personally it's a good way to get into an industry where, for us, because of our particular situation, it was kind of difficult. So
currently, how big is the team that is able to work full time from the Patreon and other donations and funding?
so the Patreon is bringing in like about $100,000 a year. I think we're hiring 3 people: our lead developer, our project manager, and then someone else. I think he's like another sort of generalist person. That's right now that's what we need, or that's what we need most. And then we're hiring 2 or 3 more people to do specific things that come from the specific sort of grants from Microsoft, from Mozilla. So somebody's doing C#, somebody's doing stuff for the web. I think we're doing another one of these 3D demos that's to sort of show off all the 3D features, and so we have an artist and stuff like that.
That's very nice.
Yeah.
But then also the community helps and participates to the development, right?
Yeah, there's about, I would say we did like a kind of a mini conference in Brussels during FOSDEM a few months ago, and there was about 20 people that were able to get there, that were sort of core contributors that are taking over parts of the development, and mostly they work for companies that are using Godot, and so they got hired because these companies, they come to us, they ask us, who can I hire because I'm using Godot, and so it's kind of an indirect contribution to the product. Companies that support us and sponsor us and stuff like that. So maybe 20, maybe like there's like about 50 people who are active like every month, and there's about 20 people who are like have big responsibilities.
That's very nice. There's a question from the stream about console developers or manufacturers. How has it been? Like, what kind of relationship do you have with the console makers?
It's complicated, I guess. Maybe. Well, they're aware of us, or some are more aware of us than others. They've been supportive for a long time, I guess. We are licensed in different ways. Like I'm licensed developer for PS4, and we have dev kits and everything like that, and they've been good to us in terms of helping us. We are licensed like as a tools provider for Switch. So for Switch, it's like it's kind of the same, but basically, yeah. So we are licensed for development for all the consoles, and then and they've been good to us. but also, there's not a lot of games coming out on consoles, so it's a little bit on us to make them notice more the engine. I think it's gonna happen, but I'm trying to help with that.
Would that be like, where is your hope? Is it Switch? Because that's like a lot of indie projects, or is it the other consoles? What would be the platform?
Well, right now, yeah. Right now, I'm more focused on Switch, for example. It's easier to go there, and most people ask about it. The people who ask for consoles, who ask about consoles, they ask like 80% ask about Switch, and then 1% ask about Xbox One, and then the other ask about. And when they ask for Xbox, they ask for all three consoles. And so and the other 20% they ask about Switch and PS4. So it's the most popular Switch. Yeah, I'm trying to get all of them, but to get all of them to work properly. But yeah, Switch right now is the most where I focus the most.
How about the retro machines? Like would there be like for the hobbyists and the game jammers that want to do their PlayStation 1 game or something like that? Is there anything?
Depends how much RAM do they have. That's a big question. We shipped a game on PSP. Those 24 megabytes of RAM. I don't know if even nowadays you can get a, because you're gonna use like 16 for the engine runtime. So then, but yeah, if you have like 32 megabytes of RAM, then we can make it work.
Yeah.
I like that kind of project, so yeah.
Good. Any questions from the audience? Okay, so let's talk about tomorrow's workshop. So you can still sign up for the workshop. It happens tomorrow at the Aalto and Vare building, and we have 2 parts of them. So what are we going to do in the workshop?
So we're gonna do a game. We're gonna do a 2D game, and then we're gonna do a 3D game, and we're gonna try. It's my first workshop, so. But I'm taking the examples from the book. We have a book, persons, the publishers. We wrote a book with them, and there's these are examples from the book, and it's supposed to be in 1 hour. You can make this example. So we're gonna take those examples, and so yeah, it's a sort of general, you get the idea for a 2D game, for a 3D game. It's like a spaceship game, and then like a puzzle, 3D sort of puzzle block game kind of thing.
So we basically have 2 1-hour game jams in a
Yeah.
row. Yeah. So we welcome everybody to there. And also, well, maybe a question about the book. Is that also open source so that people can download it and read
No.
it? Okay, so you have to buy it. Okay, so join the workshop. It's completely free, so you can get the content of the book, at least a little bit from that.
Yeah.
And we're gonna have Ariel here to chat with you. We have some coffee, or maybe if we still have some coffee in the background. And thanks for joining, everybody. This is Games Now. We still have a game jam coming up on the next weekend, and a panel on a Friday. So in the same space with the panelists, but that's not gonna be streamed. So if you wanna kind of join the panel on the Friday, you have to come in person. So thank you, everybody. Follow us on Facebook and YouTube, and see you on Friday. Bye.
Thank you.